cover is this N50. N50 is it's the measure of the assembly quality. So if your assembly is based on contigs or scaffolds, what you can do is you can your total assembly is, for example, when you put it together, that assembled genome is 200 mbps, million base pairs. So what is half of it? Half of it is obviously 100. So how many contigs or scaffolds you need to put together, or you need to just add them together, their lengths, to cover 100? So here, if we add the first one, take the first one, it's 70, and you add the second, it's 95, and then you add this third one, so that's 115. So obviously you crossed 100. Even more is good. 115 is okay, but it should not be less than that. It can be greater than that. I'm sorry. And then you take these contigs or scaffolds, and amongst them, which one is the shortest? Obviously this one. And what is its length? It's 20. So that means N50 for this assembly is equal to 20. So 20 is the length of the shortest fragment, right? Assembled fragment from a set from a set, if put together or if combined, and they are covering half of the assembly lengths. Okay, so that's 20. So N50 over here is 20. So that these tools they also give us. And now we can go back and start practicing this Linux thing. Let me switch my screens here. So everybody, I request you to pull up your laptops, right, and bring those. Is there? Yeah. So take those Linux notes or that cheat sheet with you, right, and we can practice the Linux one more time, and you can tell me which difficulties you guys were having. But do practice um, hands-on. Do it by yourself. Okay. Obviously, if you will listen, it looks really good when a trainer or a teacher is speaking, but when once you sit alone on your machine, then you get frustrated. So obviously, if you practice and you can tell us your problems, we can fix them. I mean, you might be aware that we've been working even on the weekends, and any odd time you send us a message, myself or Sadia or some of our, even within our participants, the ones who are doing good. So it's a good team. Anybody can come and help you, but you have to help yourself also. Okay. So what you do is you write Ubuntu here. So we install Ubuntu, right, and then this black and white screen comes in. So when it comes in, you have to just wait till this command or this cursor returns. So when once it returns, we can see what we can do from here. So where I am, the command is pwd. So he says you are sitting on your root. Root is the obviously the base, right, of this computer, or the ancestor. Okay, ancestor of this hierarchy of folders or directories. Directory and folder is the same thing. So on the computers, everything is within the folders, or the individual units are files, and files are put together into the folders, and then folders are put together into the bigger folders, and so on, right? So there is a parent folder and grandparent folder, right? So root is the ancestral folder, right? So right now I'm sitting at the root. I'm sorry. So what we do next is cd, and since my desktop where my files are there, so we created a folder on desktop. Obviously it's my desktop, and your desktop is your desktop. So this is my desktop, so it is online trainings. I can go here and just click here. You do right click, and then you go to properties. So when you see in the properties, it says it's in C, users, Wasim, header, and then desktop. You can just check what your path is. This thing is called as path, right? So you need to set your path right. So this is C, and then we have that colon, and then backslash users and backslash. Obviously these are backslashes here when this address is written, but in the command, that's where in the Windows. But what we are doing over here is, where is my Ubuntu? So here is it. So within Ubuntu, these are the forward slashes. Okay, so we can go from from root, we can go to where we can do ls. So when we do ls, so it's not recognized, so that means you cannot see anything, because Linux is a parallel operating system. Your actual system belongs to Windows, right? So we just need to look into, you just press tab, so the thing is working here. So this thing, you just need to enter cd, and then you go and press tab, right? So when you press tab, it writes a dot. That's what we don't need it. So we just press this forward slash, and then after this forward slash, he's giving us different options, right? So one of them is MNT, MNT or mount. So within MNT, and then you write again, you press tab, and he's just writing slash. So what if I do capital MNT and press tab? Nothing happens. So that means it's case sensitive. So I just write MN. I just write M even. So here we see how many things are starting with the word M. So he'll probably give me two options. So if I do just M and press tab, so he says either you can go to media or you can go to MNT. Media is where you are approaching or accessing a USB device. So USB is not here. We just want to go into MNT, and we within MNT again I just do enter. When I do ls, so within that he can say that you have your C and D and E. So my desktop was actually in my C drive. So obviously in your case it might be, you know, if you place your folder on D or E, you can just put then D or E here. So I just need to go to C. So CD space C, and then I do write ls. Within that, he says within that you have the options like recycle. These are some of the hidden files which he's showing. I don't need them. Program files, or you can go to Windows, or you can go to users and anything else. So what we do is cd users, and within that obviously I know that my user account is Wasim Heather, and within that I just want to go, you just press tab and he can show you options where you can go. Sorry, I pressed it 3 times or 4 times, so he's quite sensitive. So he says this is you can go from here, you can go to app and application or contacts or desktop. So I just want to go to where I want to go, desktop, right? So I do desktop, and within that my folder is, again I can press the tab character, and then he tells me that you can go to online trainings or you can go to NGS. So where I want to go, I think I wanted to go to NGS, and I do ls. So within that, these are my files which are present here, right? Control L are clear, the command clear, or control L is to clear my screen, right? So I'm just repeating what we have done last week, and I think tomorrow, and then we can go with the alignment thing, right? And Linux will be finished this week. Then next week we will be doing R, Microsoft Excel and R. So stay with us. So ls, and these are our files. So which file I just want to work? I want to work with new1.txt. So that's my read data. So the tool I want to use was fast. Fast, it says fast qc. So I just put it fast q, and then he picked it up because he has fasta-sanitize.pl and fastprocs.dll. We don't need that, so just need fastqc, and then I can get the file name. So that is my file actually, txt. I can just see somebody type this mu1.txt and it gives him or her this error. Why? Because it's not a command, it's just a file name. So you can open up that file with some commands. So one of the text editor where you can use text editors to read those text files is nano. So you can go with new1.txt and you can open up with nano. So that read file just opens it here. So here you can see the read ID starting with @ sequence, ID repeats, and these are B, 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 B. What are those? The quality scores. B means bad, right? So the third read seems like okay, but first two seem like bad. So all four records belong to one read fragment. And then this next @ indicates that this is the second read fragment, and another @ indicates that this is the third one, and so on. So we do Control X and you can get back, right? Similarly, you can open up and see some top few lines of this file. So the command is new1.txt. Head over new1.txt will give us the top 6-7 lines. How many? Yeah, we can see two read fragments, that 4 plus 4 8 plus 2 10. So 10 lines we can see. Similarly, if you have the head, obviously you can have the tail. So tail on new1.txt can show the bottom few lines, right? So there is a head and there is a tail. ls tells you that which files you have. pw tells you that where you are. So we just need to I'm sorry, go you know you just need to for example, there is another command. cp means copy mu1.txt. So anything that's written into mu1.txt, I can say make it to or copy to another file, and I name it as mu1.txt. So that's there. So you do ls and you have created another file. Where is it? That mu2.txt. So you can copy its content to another file. You can remove that. So the command is rm. So again, now when I press new, he's giving me options. So from here I can go to mu1 or mu2 or anything, right? So I do ls. So that file is removed. Okay. Remove, for example, my file .txt, and then we do ls. So that is also removed. Okay. So you can remove or clean up. I can remove dir, remove directory 31 mer, right? I can go and clean up. I'm sorry, one mer is this, not empty. Okay, no issues. So maybe I can empty that. I can remove its contents, and then this command can go. Probably I can try rm. He says it's not a file, it's a directory, but in order to remove the directory, you need to remove those contents first within that directory. Or maybe I can, why should I be not using what we have? So I can have the liberty to go and do that operation myself in Windows, right? So I can straight away go here and I can get rid of this thing, because I just wanted to create this thing a fresh new one. Right? This fast QC thing, I already had it, but I just want to get rid of that one also. This no hub I just created to write the the outputs, sorry, the commands and the outputs into this file. So obviously I don't need that, and history is also there. I just remove it. So originally we should have that these contents in your original folder, right? So I can do ls, and now everything is clean and clear. Right. So what we do is Control L, and the command is fast qc, and then the file name u1.txt, and we just wait until it runs. And we can see that those two folders, u1 underscore fast qc.html is where we get those QC reports. So any data, you can work with that and you can get those graphics. And this report, how to read that, the video is already there, but at the same time what you can do is there is one tutorial. I guess we shared this Galaxy one. There is the one that is Galaxy. I think it's there on your WhatsApp group, so you can just have and read those things from there also, or you can see that video lecture, right? All right, so we also did Velvet. So Velvet, and within Velvet we had Velvet G. So Velvet G, and then Velvet G is do that genome assembly. But before that, I think we did Velvet H. Let me see my cheat sheet. So I can just go to this second one. So sudo apt install Velvet. We already did that. So Velvet H. Velvet, I'm sorry, not Velvet H, and I'm creating a folder named as 31 mer, or just I can say I can call it as my kmers rather than 31 mers, right? And kmer size I just defined. I can go with 33 also or 30 also. You can just try with these different numbers. And input file is in fast. That's in dash means options, fast q format, and it's the short read data, because nowadays we are getting the third generation data, that is the long reads in kilobases, and the original file is v1.txt. Before we do that, I just for example cut it from here to control X. So probably this control X should work here. No, it's not working. So I just need to do ls before, so I can see that there is no folder here with the name, control V, or you can just do right click. So yeah, my command is saved. It's saved with control X, but still it was written. So I just do enter, and then I do ls. So we see there is this my kmers folder that is there. I'm sorry. You can do ls, and then you can write my kmers, and then we have log and roadmaps and sequences. What we can see here within logs is maybe we can do head over my kmers oblique log. So here is the kmer length and the commands which I'm giving, and this 2008 to 7 Velvet H kmer 31 this version 1.2.09, and copyright in 2007 and 8 by Daniel Zerbino, that is the author, at ebi.ac.uk, European Bioinformatics Institutes. This is a free software. See the sources, blah blah blah. No warranty. Use at your own risk. But everybody is using that. Don't worry. All those open source tools, they get you this warning, but no one cares, because we know that these are standard and everyone is using them, and huge community is using them. So that's why we follow, right? But depending upon your species, so in your case, if you're working with microbes, so people, they recommend spades for prokaryotes, so it's also good. All right, so we do ls, and then the next command is I just copy from there, or I can just type it. So control, I can go here, control L. So what I can do is velvet key, and then my kmers. I just need to show him the way, and he will do whatever he wants to do. So he says that final graph has 44 nodes, like I made 44 of these contigs here. So right now it will go up till contig levels, and N50 is 109. Maximum, the longest or largest contig is 535. Total I guess total contigs here are 4481. Nodes is what is that? Yeah, so within that, when it solves this problem, it uses the graph. So within that, he created nodes. So nodes are the individual points. If you go here, this was the overlap. sorry, de Bruyn's graph. So in de Bruyn graph, what happens over here is all those uh, these um, these k-mers are placed together here in the shape of a graph. So individual units in the graph are called as nodes, right? So if this is your Facebook network and here you are and here is your friend and then other friend, then you are all connected with each other. So you are nodes here, right? And within that, these are the edges. The connections are the edges. So nodes and edges, that terminology is coming from those graphs or graph theory. So that's what it is. Okay, so that statistics is there. You do ls. So again, within that my k-mer, so we can do up arrow key and we can repeat the previous command. So ls and my k-mers, now it got additional files. So one of them is context.fa. So what you can do is head over my k-mers. Within that is context.fa. So that is the first config, node 1 of length 155 underscore cov, and then it has 1.66416. I think that is the sum of these numbers, this 4481. What we can do is we can take these numbers 155 and 64 and 69 and all of them, and then we can just add them and we can see that the total assembly length was how much. So I guess the total nodes we had it, or we can get it with grep. So we can go with grep and grep, and then we say c means count. So count the word node, node, and within the file named as, what was the file? My, since I'm sitting one step above, so I write the folder name my k-mers and then context.fa. So it says 42. So 42 were the total nodes which we get. So final graph has 44 nodes. Why these are not 42? These are 42, he's saying. But here in the statistics, he says that it has 44 nodes. And I think that is the total assembly length. Maximum, the largest is 535, right? So, and then the total 4481. We want to see which one is of the length 535. So what I can do is grep, and then I can just, if you remove C will just count them. Okay, so when you do here, so grep, and I just put the word 535. Obviously, it's unique. So within my, I'm sorry, context, so it's node underscore 11 length. So node 11 is of length 535. Right, so that is the one. Okay, so maybe I can just capture the nodes. So I can go like this and I can simply put it into a file, nodes.txt, for instance. So they will be stored here. So grep will simply bring them out, and I can go here, for example, right? So nodes are 1 2 3 4 5 6 7 44. I don't know, I mean, why my command just screwed up, and grep gave me, rather than 44, it gave me 42. So they are 44, by the way. His statistics was right. Node, maybe in sometimes we might get some spelling, but obviously they are the same. So why grep was returning me here? He's returning me correct. So grep C node on this. Maybe I can put this underscore thing also. So sorry, count node underscore. Again, it's giving me 42. single quote. Difference, by the way. Again, he's giving me 42. I can double check this thing with Excel. Maybe he dropped a couple of them, but I'm conscious because these numbers should tally each other. So we can go to Microsoft Office, and within that Office 16, I'm sorry, I can go directly to Microsoft Excel. So far, if you have any questions, just let me know. So I can go from here, file, and then I can go open, and then I can go to home, sorry, open, and this PC, and within that browse. All files, not all Excel files. So contigs, no, sorry, what was the name? Yes, on NGS, the name was nodes. Right. So next and finish. See here, they are 42. So in counting, I think he has deleted, because my trust on grep, it's like 10 years, more than 10 years I'm using this, so it never disappointed me. I just wanted to double check that. I can just sort on this 1 2 3 4 5 6 thing, and then we can see which one is missing. So there is this 1 2 3 4 5 6 7 8 9 10 11 12. Yeah, 12 is missing. Maybe that was less than the expected, so there is a minimal length he's following, and then there was probably one more should be missing, 17 18 19 20 1 2 3. Definitely one of them is also this. 27 is also missing, right? So node 27 is also missing. So obviously 42 nodes, that's it, right? A node means those contexts which he has created. Don't save. Right, so up till now I've just repeated the previous thing, and then I think that's all which so far we have done. If you have any questions or queries, let me know. I can just wait, and still we have a lot of time to fix your problems. As per my promise, this is your repetition class, so maybe tomorrow we can take the new topic also. Okay, so just let me know. Any questions, queries, concerns? See, most of the people are missing.
No, sir.
Okay, so I'll stop sharing, and I would like to say you goodbye. We hope for the